Welcome to this session. This session, we are going to see how to change a denary number to octal when the denary number is having a decimal point. So from what we have done before, we are just dealing with numbers which do not have decimal points. But a case whereby a denary number has a decimal point, then we must look further than what we have been doing for the case of numbers without decimal points. So to change, for example, to change the number 0.526 to base 10 to octal form, we multiply the decimal repeatedly by the new base, and the new base for this case is 8. But on the second and subsequent multiplications, we do not multiply the whole number part of the previous product. So you see now the process is different from the other case when the number doesn't have a decimal point, you are dividing. But this case, when you are dealing with the decimal number, you multiply. But then you multiply in such a way that the second and the subsequent multiplications, we do not include the whole number part. For example, if you get the answer, if you have assuming your answer is 2693, then the subsequent multiplication, you don't multiply 8 by 2.693, you only multiply 8 times 0.693. That's what you mean. Now let's see how that one works. So we write 0.526, then we multiply by 8. Using your calculator, when you multiply by 8, you get 4.208. And then in the next step, you multiply by 8 again. But remember, this 8 will not affect this 4. You are multiplying 0.208 times 8, and that will give you 1.6664. So you don't include this 4, you just include the decimal part alone, 0.208. And then next, you multiply by 8. And then remember, you don't take 1.664, you only take 0.664. So 0.664 times 8, that will give you 5.312. And then next, you multiply by 8 still. But remember, only the multiplication affects the decimal part. So 0.312 times 8, that will give you 2.496, and then multiply by 8. So 0.496 times 8, you get 3.968 etc. So the biggest question will be, when are we going to stop on these multiplications? So we are going to stop when, so remember the first thing, this first, in fact, 0.526, you can just write as 0.526 so that you don't confuse, because we are going now to pick these whole number parts as our answers. In this case, we are interested with the whole number parts. So these whole number parts are the ones that are going to help us get the answer to our problem. But then we need a stopping criteria, and the stopping criteria will be simply saying, so finally, we write the whole number, numerals or digits downwards. Now this one is just direct, not like what you are doing in the previous case of bottom up, downwards to form the required octal number or octal decimal. So, but be careful not to include the 0 unit digits in the decimal, in the original binary decimal. In fact, it is safer to simply write .526 .526 to base 10 instead of 0.526 to base 10, so as to avoid confusion of including 0. So therefore, now in the example we have done here, so that's just say that you can just write 0.526. So remember, when from where we started from, we gave some examples, like if you have a number 214.357, to write this number in octal form, then you write 8, 8, 8, 8, 8, 8, and then after the decimal point, this usually put 0, 1, 2, etc. on the left, and then immediately after decimal point, the first one, you write power -1, next power -2, power -3, etc. So therefore, for us to know the stopping criteria after doing this several multiplication, we just know that this first non-zero digit, the whole number part, is the one that we are going to include. So it's like we have the value total value will be 4 times 10 times 1 over 8, or 8 raised power negative 1, plus next one will be 1 times 1 over 8 squared, and then the value of the next number would be 5 times 1 over 8 power 3, and then you try to get these sums to see whether they are agreeing to the decimal we have 0.526. For example, if we are to add this one, 4 times 1 over 8 plus 1 times 1 over 8 squared, assuming that's where we reach, the answer is 0. Up to this point here, we get 0.5152625. You see 0.512625 is far away from 5.26. So we have to add this other part. When you add 5 times 1 over 8 raised power 3, that gives you 0. Up to this point, you get 0.525390625. You see, when you round off this number to 3 decimal places, what is given, it will not give you 0.526. So you go to the next one. So the next digit is 2. So 2, and then its position will be 2 times 1 over 8 raised power 4. So plus 2 times 1 over 8 raised power 4. That will give you 0.525878906. Now you see, when you round off this one to 3 decimal places, you'll get 0.526, and which is the same number that was given. So therefore, it means that if this whole number parts, we have to stop at this point here, so that what we have will agree with our decimal number. So therefore, we say 0.526 to base 10 is the same as 0. Remember here, when we are taking this whole number parts, we take just them from the beginning. It's not the reverse like what we did when we don't have a decimal number. So before 152. So 4152, and then this base 8. So these two numbers are the same, or you can write it as 0.526 to base 10 is equals to 0.4152 then to base 8. So that is how we convert that. Next session will give another example to illustrate how to do when we have both the whole number part, which is not 0. So for example, if you're asked to convert, say, 2.389 from denary to, say, hexadecimal, how do you work out in such case? Thank you.